Welcome to this video on exponents, and as I mentioned, it probably would be better to call this a lesson on powers. It's just that exponents are kind of what make a power special. And what I mean by that is you've been working with exponents since you've been working with numbers, like 3, 4, and 5, technically all have an exponent in them. It'd be like there'd be a 1 up in the corner here. All right? It's just we don't usually write that exponent because it doesn't affect the value. Okay? So think of a power as a regular number with an exponent in the corner. Okay? So power has two elements, the base and the exponent. The base is the bottom. Okay? Think basement. You have a basement in a house, it's on the bottom, it's below. Some say, well, it's the big number. So whatever way helps you remember that the base is this number right here. At the bottom, and the exponent is this small little number over here. And it's kind of weird, but I think of it like a gnat, a tiny insect that's kind of flying up by your ear. All right, there's more reasons than that, but we'll get into that later. All right, so this is the exponent, this is the base. The whole thing is called a power. All right, and then it says the base of the power is a factor that is multiplied repeatedly. Repeatedly means it's the same thing over and over and over again. So the base, 2, gets repeated. 2 times 2 times 2 times 2. And then the exponent of the power is the number of times the base is used as a factor. So 2 gets repeated how many times? Well, it gets repeated 4 times. So 2 times 2 times 2 times 2, that's 4 times. 1, 2, 3, 4. So 2 to the 4th power. Okay? So that is our expanded form. This is exponential form, or power. Okay? So we did a little practice here. We decided the 7 would be our base, and our 5 would be our exponent. All right? And then 4 would be our base, and 8 would be our exponent. All right? And if we wanted to go further, we could say this would be 7 times 7 times 7 times 7 times 7. I think that was 5 times. I lost track. But you get the idea. All right? Down here on the bottom of page 9, we looked at the area of these squares. The square is a specific shape because all the sides are equal. So length times width would be the same as area equals side squared. So the length of the side is 9, so 9 squared would be 9 times 9, which would be 81. All right? Because 9 to the 2nd power means we're going to repeat 9 2 times. 9 times 9. All right? And technically what we call these things are perfect squares. Okay, 9 is a perfect square because it's 3 times 3. All right. Then for volume, if we go down here, volume is length times width times height. So it's 3 dimensions. If it's a cube, all 3 sides are the same length. So it would be s to the 3rd power. So whatever our s is, our side, would be to the 3rd power. So we want to do 2 to the 3rd power. 2 is our base, so it's 2 times 2 times 2, because we're going to repeat our base 3 times. Okay, which would give us 8. Because 2 times 2 is 4. Times 2 again would be 8. And be careful here, it's not 2 times 3, okay, which would be 6. That's not what we're doing here. We're repeating 2 the number of times that the exponent tells us to. So 2 times 2 times 2. All right, same over here. 4 to the 3rd power, since these sides are 4 inches long, would be 4 times 4 times 4, which is 64 inches cubed. All right. So basic idea, remember your base tells you what you're repeating, your exponent tells you how many times you're repeating